Okay, so just a very brief recap of what we're going to do. For future us and anyone else who is interested, we're going to walk through the work that we did to migrate Redis rate limiting from Redis Sentinel on VMs to Kubernetes, and just walk through the issues that we did and generally discuss. So yeah. Do you want to start, Bob, or do you want me
Yeah,
to start? Or go ahead.
yeah. So the way I think I set up this project at the beginning was just start with the different
You sure did.
environments. So the way we tackled that was we'll do pre first, then we'll do staging, then we'll do production. And staging is the closest thing that we have that would resemble production in a way of doing things because we already had an instance to start from. In pre, we just needed to tweak it a little bit to not be a mixed Redis instance. So with a mixed Redis instance, I mean um, sentinels in VMs and other sentinels in Kubernetes that would have a replica and then we'd fail over. That was the initial plan we had. But we decided against that because we didn't need it, because we didn't really care about migrating the data that only lives for a few minutes and just, uh, yeah, do a clean switch in the configuration and go that way. So the first thing we did was create these pre-issues here. So update the Redis slate trimming instance to be standalone, and then start using it from the configuration. Um, when we did that, we got to see a bunch of things regarding our existing metrics. So that's the observability issue here. Lots of things were like not not working because they were relying on an FQDN label to be present. So we need to update that to use the instance label instead, which is based on IP address port name rather than domain name. Um, we were doing that in parallel. In parallel, while we were spinning up we were doing the same work for staging. For staging, spinning up a new Kubernetes, like there we need to start with a brand new Redis instance. Spinning up a new instance meant creating the designated node pool in Terraform. Stephanie, you're probably going to be better, so if I forget something, interrupt.
I will.
Spinning up, spinning up the new, like preparing the new node pool in Terraform, adding the new Redis instance to our Tanka deployment setup. Everything there was already prepared by the frameworks group who was working on the container registry cache instance. So we just used their stuff and tweaked it where we needed it, like where we needed slightly different configuration and so on. So after we done that, we could just switch over to use the new Redis instance in staging. And there we noticed some problems because, well, nobody we couldn't get this right from the first time. The first problem we noticed was a different database name and different secrets. So then we needed to correct the database name for Redis Sentinel to be this magic string my master, which is the default database name for Redis. And then there was the thing with secrets being stored in GKMS that was still used by VMs. And by VMs here I mean Redis clients. So that's basically just the console hosts left, but those couldn't connect otherwise.
There was also
Uh,
the issue here of we had not originally set up external secrets correctly to start with. In there's an external secrets in Kubernetes that was not set up correctly. There was an external secrets object. That one is slightly farther above where it says rotate Redis rate limiting secret on staging. And there was a separate MR that we had to create for that. That once we did that, it was there. There was also when we were creating
The load
staging.
balancers.
Oh no, I haven't even touched on the load balancers yet. I was
Okay.
also noting that when we created staging, we also forgot that we had to create a secret in Vault, and there was all the back and forth of where these secrets lived because they moved in between the first setup of these things in Kubernetes and this one. So like for any future people, make sure you have all of your secrets in place before you do this. Otherwise it does not work.
And if I got it right, we've got the correct helpers now in the Tanka deployments. Like it's a helper method that you can just call. This is what the secret called. This is the environment. This is the namespace, and it will build the string to get the secret from the right place. But you still have to manually add it to Vault. So
Correct.
you need somebody like Stephanie with superpowers to add that in the correct place.
And that is the one piece that I know that the reliability team is still doing an enormous amount of work with Vault. So that may change at some point. But yeah, that was the one piece that Bob could not do by himself.
No, there's another piece that's coming now.
Oh, right. Yes.
So when we did the actual config change, we weren't super careful with staging because, well, that's what staging is for. So we broke it and we had to revert it. When we made the configuration change in staging, so first we broke it because we forgot about the secrets. We fixed that, and then we could access Redis from a console. But then when we proceeded to roll out to everywhere, we were getting 500, and that was because the clients, so the Rails application, couldn't access the Redis instance because the load balancers didn't allow them to.
That is correct. Yeah.
Could you explain how you fixed it?
Sure. The way that we had set this up was all of these are running load balancers within Kubernetes. And one of the issues that we ran into was that we have moved some of the things that we're using outside of the same region as where these Kubernetes objects or where these Kubernetes clusters are. Specifically things like console, which is moved to a different region for DR purposes. And all of our Kubernetes load balancers were not set up to allow, what is it called? They needed to be set up to allow essentially global access. I'm trying to actually go and find the issue, but it doesn't really matter. So what we have done is we spent some time trying to debug exactly, there you go, what it is. And then we set it up so that it was actually now using the annotation for global access, which is essentially saying that we can access these load balancers from anywhere within the same VPC. As part of this work, we've actually made that a default across reliability as well. So hopefully nobody else loses a full day and multiple brain cells trying to figure out what was going on here.
I was about to ask, would that be a safe default to have? But
yes, it is.
Apparently, yes.
It's a safe default, and it's also now the default for Redis as well. We made that the default as part of rolling this out. So
that's great. Yeah.
Hopefully we have saved this for the future. But yeah, it's the actual annotation is internal load balancer allow global access.
Cool. So then we had it running in staging, and it was time to prepare for production. We prepared a readiness review. That's like a markdown document in the readiness review project, and we could reuse a lot of information that was already collected for the registry cache instance. But yeah, some things were our own because this instance already had quite a lot of traffic. So slight differences there. When that was approved, Stephanie and I started to prepare the change. So the change issue with different steps to roll it out. On Igor's recommendation, we stepped back a little bit and we went from just doing Canary everything to Canary one region at a time, or one zone at a time. I don't remember. One zone at a time.
It was one zone at a time, yeah.
Yeah. So when we were
And
doing that, yes.
the original plan was going to be Canary, and then I think US East 1B, and then everything, which we changed midway through this, but you're going to get to that.
Yeah. So during the rollout, we did Canary and then let it sit for a day to just see the thing with traffic. During this day, we would effectively have a split brain for rate limiting, because traffic going through Canary would not count towards the rate limits that's otherwise counted in the Redis instance in VMs. But we decided that that was acceptable, but we couldn't have that for more than a day with more traffic than just Canary. So our plan for rolling out was doing a single zone first, and then immediately proceeding to the entire fleet. When we did the single zone, we did notice that the CPU utilization was higher than we expected. Like, we would expect to be at about 1/3 of CPU utilization, and compared to Redis and VMs, we were much higher than that. That's when we decided, like, let's not do everything right now. Let's do one extra zone before we do the whole thing, which is what we did. And then the three of us, Stephanie, Igor, and myself, made the call that we would not proceed because we were already like close to like 60% CPU utilization with 2 zones, and that's about as high as the current CPU utilization is at peak time on VMs. So we decided to stop there and investigate further what we do.
Yeah, and just another quick note, the difference in CPU between one zone plus Canary and 2 zones plus Canary was about 20%. So we were running at like 40-ish% with one zone and the Canary. And then when we went to 2 zones, we were at 60%. The logic was that we would probably be close to 80% with 3. And that gave us very little headroom, especially since this is the fastest CPU that we have, that GCP has, and Redis is single-threaded.
Yeah, so staying there would mean we've effectively moved the saturation, the moment of saturation closer, and we don't have a horizontally scalable solution for that yet. If we did, then this would have been just a case of adding some more Redis, and then we could continue. But that's what we're going to be working on next.
So maybe I should walk through briefly the CPU increase investigation, which is long. So after we got through this, we rolled back everything in production and left us with this running in staging and in pre-production using the VMs. And Matt and I got on a truly epic, like 4-hour-long Zoom where we walked through a lot of flame graphs. And essentially came up with, Igor during the actual rollout had offered a thought that perhaps this was related to Redis networking and things of that nature. Matt and I fairly conclusively proved that that was the case, in that someone, I think it was Philippe actually, also confirmed this. We're using Calico in our Kubernetes, and because of its hybrid approach to control traffic, which is IP tables and a bunch of other things, there was approximately a 30% increase in CPU time for anything that was, yeah, like 25% to 30% during incoming packet processing and packet processing as a whole. This explains the, explains the general overhead of CPU. It's also, unfortunately, something that often comes whenever you add more layers of abstraction to a system. They often don't come free. In this case, this was a much higher hit than I think anyone expected. And the reason that we discovered this during rate limiting and not during some of our previous work is that rate limiting is very connection heavy. I don't know if it is the
short, fast calls, like very
yeah.
many calls. That like every request makes one.
Right. So lots and lots of connections, which meant that the overhead for any, like this connection overhead was hit rate limiting worse than it might other Redis instances. In that if we were doing fewer connections that were slower, it would not have been quite as much of a CPU increase. So for better or for worse, picking this was a good candidate to discover this exact problem.
Good point, because we did do load comparison tests on Kubernetes and VMs before this project even, and noticed there that like everything was quite similar, but I don't think we've replicated the Calico thing.
Right. And unfortunately, it's just, I think rate limiting might, I mean, I suspect if we look into the future, that rate limiting would still be one of the most impacted by this, no matter what we do. And that if we had picked something else, this would have been a project that we were talking about as one of the best, most elegant rollouts that have ever existed, and everything just worked.
One thing that this also makes clear, we wouldn't be able to fit Redis cache or Redis persistent on Kubernetes just like that. We would
Correct.
need something more.
Yeah. So
that's it, I think.
Yeah, I mean, essentially, we're going to, we haven't actually completed this work yet, but you can see there that there's the revert back to using Redis rate limiting on VMs in staging and pre. We're going to be pivoting to do work on how to do horizontal scaling. But I am, for future me and for anyone else who watches this, I do think that this was an extremely interesting project. And we learned an enormous amount about, doing Redis on Kubernetes.
Me, anything on Kubernetes really, but
sure. We very, very well tested, the work that Igor and Alejandro had done in order to do this first piece. In that, Bob and I took it over and totally managed to do it all without breaking things mostly. And the actual rollout was rollout and rollback was very smooth. Like,
and I think that's also something that I think we should call out. The rollout and failovers and stuff that we did wouldn't work easily on VMs. There we would need to do more fancy things with stopping chef client, doing a change, starting chef client on a single machine, and then the other machine, and then the other machine. While on Kubernetes, that was just merging a merge request and then watching graphs change.
Yeah, the actual, like all of the pieces of managing this in Kubernetes was much easier. We just need more CPU.
And we can't get any.
We can't get any. So, as a whole, it was also the other piece I think that is worth noting, due to time zones, Bob and I decided that we were going to roll this out during some of the highest traffic periods that we have at GitLab. I actually think that worked in our favor in that we discovered that we could make all these changes and no one noticed. But also we saw the highest traffic and thus everyone was there watching it and being able to compare. Had we looked at a lower CPU time, it would have been harder to see the difference in the graphs. Not impossible. This is a pretty significant difference, but harder.
Yes, worth calling out that we needed to proceed immediately. So the fact that we did this on because of the split brain issue, we needed to proceed immediately. But because we were doing this on a high traffic moment, the problem surfaced when we were working on it, as
Yep.
Stephanie mentioned. If we hadn't done this, but had done this like in the downtime, then this would have been the problem of the on-call, I think, because I don't know
Yep.
if we would be too close to saturation or not, like close enough to trigger alerts or not. Like it would be borderline, which is not a great place to leave stuff.
Yep. The only other piece that I think is, again, worth calling out is I do think that Bob and I did a great job during this thing in like doing like handing over the work back and forth and being able to move faster because there were two of us in two different time zones. So like Bob would do a bunch of work during his day. He would hand over things to me. I would update. I'd hand back to him, etc. And I think that meant that we sped through the last periods of this much quicker than I originally expected.
Yeah, because that we were also on a roll then, right? Like approving from like just the work, getting the approvals before
Yep.
you came online, and then getting the approvals from the SRE on call and so on. Everything was ready, and we just needed to like meet and then
Yep.
get it done, and then get it undone.
And then get it undone. So yeah, I mean, overall, this was really useful. Definitely, like, I think we've proved that we can run Redis in Kubernetes with this, just if we also had horizontal scaling.
Yeah.
Cool. Any other last words before I stop this recording?
Nope.
Cool.
Not for me.